if I change resistor 100 ohms to 25 ohms. So let's say, any questions about it? This is all good, it's all cool. Let's say I change this, so I'll keep all this. You can keep it too, but we're gonna change this to 25 ohms. Okay? So let's say I change this to 25 ohms. Let's see what happens. So this here is now, everything is the same. It doesn't matter. Okay? Still the same. So right before switching, inductor is short, still will be minus 60 milliamps. Capacitor is open, charged up, both charged up, 15 volts. Move on. Switch moves, you still have parallel RLC, still natural response. This is 25 ohms here now. Okay? Shit now. And we're gonna do. Try to explain that to you. Go ahead now. Now, when you do 25 ohms here, that's what's different. That will give you so alpha in this case is 4,000. No. Yep, 4,000. And omega 0 is 4,000 as well. So now you have they equal, which means that alpha is equal to omega 0. You pick the third case, critically damped case. Critically damped case. Okay? So now when you do that, the formulas for will be different, okay? The formula will be now for this, you have this now. Instead of this, now you have a critically damped case, a response, critically damped response, and you have this now. Formula is V1T e to the minus of e plus V2 e to the minus of. Okay, so you still have this circuit. We'll look at it. We have inductor, resistor, capacitor, L, R, C, IL, IR, IC. And they all share VC. They define at least. You define D1 and D2 in this case. Alpha, you know. So you have two equations. Again, VC0 plus will give you D2. So you plug in 0 in here, you get that's equal to D2, which is equal to 15 volts. Okay? And D1 then, to calculate D1, you do again dVC over dt as t equal to 0. And that's equal formula for that, when you take a first derivative of this, that is equal, you can do that, look it up, D1 minus alpha D2. Okay, and that's also equal, again, IC0 plus C, right, like we did in the previous problem, which is minus IL0 plus minus IR0 plus divided by C, applying KCL, which is basically, this is 60 milliamps or minus 60 milliamps. And this is again 15 divided by, over here we have 25 now, right? Whatever that is, okay? Was that? Is that correct, what I did? So basically what you get here, when you do it, they say you get minus 60,000. That's minus 60,000. And then this is, that's equal 10 to the minus 6. Be careful over these units. Some of you will fuck this up, I know. Guarantee you that, because I've seen 30 years I've been cleaning into your brains. Please, be careful about it. Don't be that. Don't be that sucker. Right? You'll still get some points, but it's hard. You know, if you screw up, if you don't get the right equation, then it's really hard to give you a lot of points. Get it? You'll get 5, 6 points. Instead of 10 or 18, something. Even if you screw up the math, but everything is correct, you'll get 18 points. You'll get an A in this class. But if you don't know what you're doing, God, it's hard to grade. Right. So, D2 here, D1, when you calculate, is equal, no, oh, I'm sorry, D1 is 60,000. No, D1, this is whatever that is. So when you calculate that, you get a minus 60,000, that's volts per second. Okay. No, actually, no, hold on. No. Take it back. This is minus 60,000. And then you get, this is equal, D1 is 15 minus 4,000. D2 is equal, no, D1 minus D1 minus alpha 4,000 times 15 equal minus 60,000. What is that equal? D1 is equal to 0 in this case. Okay, you got it. So your VC of T is basically, since D1 is 0, you got a V2 is equal 15 e to the minus 4,000 t volts for t greater to 0. And then again, we can do IR of t using Ohm's law. VC of t divided by 25 ohms for t greater to 0 plus IC of t is C over dt. Whatever that is, you move from alpha over this. If you are uncomfortable with derivatives and integrals, IL of t is equal to minus IR of t minus IC of t, or IL of t will be equal 1 over L integral VC of t dt from 0 to 0. Well, from 0 to t, not to infinity, because you need from t greater equal 0. Any questions about this one? Same thing, just that's different formula. There's a third case as well, and we'll do that now too.